Hello and welcome to this new edition of Frenchkit. And I'm Stéphane, engineer at Publicis, and today I'm going to share some tips with you to better secure your application. First, we must answer a fundamental question: what is security exactly? And to put it simply, we can say that security is to preventing someone from retrieving or corrupting data or creating malfunctions on your application. It's really simplest, but keep in mind that someone can be you, me, your users, activists, companies, government, and etc. It can be a lot of actors on this part. Someone may blackmail you for money or ruin your reputation. For example, someone can expose some leaks inside your app and divulgate this information on the social network, for example. And someone can steal some intellectual property, and that's why we need to care about security. And of course, there are a lot of things to cover. And if someone is able to crash your application all the time, it can dissuade your users to using your application. That's why we should care about that. And don't get me wrong, security is a vast area. I cannot cover everything in 25 minutes. But today I'm going to share some tips with you. And it's up to you to go further. Here we have a sign-in page, and I will show you some bad practices. And let's begin. Okay, it's not a production code, do not blame me. Everything is right. So what's wrong with this picture? On the top, you can see that we have a strange global communication, and we want to avoid that someone can easily trigger sensitive events from everywhere. For example, in iOS, we have NS notifications, for example. And on the middle, just here, we have a non-HTTPS endpoint, which means that everything is transiting in clear. And so we can fix that very quickly. Now we have removed global communication by a completion, which is great. And as you can see, we put an S behind just after the HTTP. And now our requester handles TLS spinning. TLS spinning in general is a technique that we use in the client side to avoid the man-in-the-middle attacks. And here is an example of code which ensures that certificates from the client and the server are the same. And just after that, I will show you some why and how can we hide the strings in our binary, because we don't want this kind of information is available in our final binary. By using HTTPS, we secure data within a communication pipe between your app and your server, and it prevents someone from catch information. And it's up to you to add encryption, and if you can also encrypt the data itself if you want. Keep in mind that the more, the better. And for example, you can use AES encryption. Now we can take a look our sign-in page with Hopper. Hopper is a disassembling tool, and this one will allow us to read the assembly code. On the red rectangle, we can notice that we have some API in clears, such as some symbols, names of variables, API on the top right, and on the bottom right, we have some lifecycle of our app delegate. And if we deep dive just a little bit, we can identify at the top that we are here in the Authenticate API, as we saw previously, which try to create an object with this specific endpoint. And we don't want that this kind of information is clear in our binary. And I will continue. It's time to obfuscate our app. And to reach my goal, I'm going to use IXGuard, which is a complete solution, but it costs money to use it. And if you want to learn more about security in general, and on the mobile in general, I recommend you to visit this website. So, When we are coding, we need to cover some aspects such as readability, reusability, understanding, etc., etc. Not only for you, but also for your team members. And don't get me wrong, it is totally great. However, sometimes we don't want to. This is where obfuscation begins. On this slide, you will see the layers of protection we will cover next. Let's start with Swift inline feature. This feature is free. It comes with Swift. And this feature allows you to remove functions and duplicate its content on each callers. Allow me to be clear with an example. At the bottom, we have an API, just here. And this API is called twice, as you can see on the middle, on the top. And inlining this function will remove this function and duplicate its content twice. What does it mean? It means that if someone wants to hook a specific API, you have to do it everywhere now, because the code has been duplicated everywhere. And I recommend you to use inlineable and usable from inline, because the compiler is smart enough to cover 90% of the cases. However, you have to use inline always for the remaining 10%, and you have to use tools like Opera to verify if the job has been done. And the next one is just a reminder: be sure to use an encrypted communication pipe, and you can add many layers of encryption as you need. It's really important. Now we can talk about API renaming. As I said just before, this kind of code is really useful for you and for your team members because it's readable, short, understandable. But we don't want, however, we don't want that in our final binary, in our production binary. That's why we use tools like IXGuard to cover this job for us by renaming every API, every variables. And now, as you can see, it's a little bit complicated to understand. And if we take a look carefully on here, we can see that IXCode has also injected some API, and it means that all strings will be deciphered at the runtime. Nevertheless, there is some limitation, because it doesn't work very well with object which inherits from Objective-C classes. And if you want to learn more how it works under the hood, I invite you to take a look at Sourcekit and Swift syntax. Now we can take a look at jailbreak detection. If you don't want that your app runs on a jailbroken phone, for example, on a banking app or other services which is critical, you can try to find if CGI is present, because jailbreaking is actually a really intrusive process, and you can find a lot of them. And another example is to access to weird storage files outside your app sandbox, like bin/bash, for example. And you can also try to find files outside your sandbox. And that's the main things. And you can also add additional flags on IXGuard YAML file to allow you to detect if the phone has been jailbreaked or not. And keep in mind that jailbreaking changes all the time. That's why you should keep an eye on jailbreak evolution to be up to date. Now we can talk about static libraries. The main advantage of using static library is that its binary is merged with your app binary, unlike dynamic, which is loaded at the runtime and only if needed. It means that if someone wants to replace a dynamic library, he can. Here is an example to find and locate frameworks. First, you need to find an IPA, unzip it, go to the payload, and you can see the framework folders. On my example, I am using Alamo Fire, which I am using the 5.2.2, And when an attacker knows his information, he can download the original project if this one is open source and build his own SDK and replace yours. And if we made some changes, if I replace the Alamo file with a static library, we can see that our binary size is increased and there is no more framework folder. And now it's time to go a little bit further with control flow. And don't get me wrong, this part is really complex, and I want to simplify to be understandable for everyone, sorry. And what do we mean by control flow? When we talk about flow, we are referring to the order of the execution. Here is an example. We can see that we are executing the block A after B, following by the C and the D. And we don't want any changes. That's why it's really important to control the flow, because we don't want any hackers to hook any APIs. And, sorry. And it's really important to do not show your structural flow inside your binary production. That's why we use some technologies and tools inside special compiler, like IXGuard or others, to flatten the code and make it difficult to understand. And to put it simply, we can say that the gray rectangle will dispatch and call any APIs, and at the end of each calls of each API, they will recall the dispatcher. We can say that this one is a huge switch case, for example, and it makes it difficult to understand. That's the job of this dispatcher. Now, we can talk about code integrity. And verifying the integrity of the application at the runtime is one of the key elements in the well-protected environment, such as jailbreak detection, if someone is trying to hooking your APIs, or changing any frameworks, for example. And it also allows you to detect some runtimes, some weird runtime events. For example, if someone is building a third-party app, it can also trigger some sensitive event outside the sandbox and inject or retrieve some information from your app. For example, when we build some protection, for example, to detect jailbreaking, some third-party apps can also inject hooks, the compiler, to retrieve and remove everything inside your app at the runtime to remove any detections. That's why we use some tools to cover this area. To give you a picture of what I'm saying, this is what we want, a perfect environment, and this is what we don't. And I suppose it's really clear for you. And to summarize, it guarantees that your code is authentic, and in case of changes, a report will be sent through a callback or directly on your server if you link this one to IXGuard. And it's really useful when an attacker attempts to modify, hooks, or debug your code. And building your own solution is possible. However, it's extremely time-consuming. That's why we use a third-party compiler to do the job. And here is a random stuff, and I would show you and to share you, sorry. And what is, first I want to show you how IXGuard looks like, our IXGuard file looks like. Basically, it's just a YAML file, and you have to toggle some flags you want to cover. For example, if you want to cover some environment integrity and jailbreak detection, you have to toggle some flag in addition of your initial protection, of course. And if you don't want if you want to encrypt some aspect in your asset catalog, you can do it too. However, be careful about that. it will not decipher anything on the splash screen. And here you can see at the bottom we are a batch of booleans to toggle the integrity code. And here on the top you can see the line where we put to cipher strings. For example, if you don't want any your endpoint in clear, you can whitelist them, and IceGuard will remove and decipher. Sorry, they will remove the string in clear your binary and will reconstruct the endpoint at the runtime for you. So how to install it? It's really simple. Basically, you have to install a macOS package, and you have to deal with 3 command lines. The first one allows you to read the documentation. The second one allows you to obfuscate your app. The first argument is the destination of your final IPA, which is obfuscated. And the last one is the path of your initial IPA. And the last one is really important. It allows you to resign your application with another Apple certificate. It means that if you want to test, for example, another application with different certificates like development or production, you can do it with this command line. Previously, we saw amazing features about runtimes. It can be really amazing. We saw about toggle features and others. However, if you have some sensitive code which includes data and sensitive cases, do not use runtimes feature, because we don't want that someone can easily trigger sensitive events from everywhere or inject any data. And for example, I recommend you to avoid class reflection, because someone can easily inject some classes inside your binary and call it from the NS class object. And I recommend you to use Swift instead of Objective-C, because Swift has a huge lack on the runtime feature. And the last tip for today is to implement device check. Device check is provided by Apple, and this one is free. And you have to implement it on both sides. On the client side, you have to retrieve a token and send this token to your server. And on the other end, on the server side, you have to send this token to Apple, and Apple will respond to you if everything is correct or not with this particular phone. It's really useful to try if something has changed at the runtime or if Apple has detected anomalies in your application. And it's free to use. It's up to you to implement this feature. And I would like to thank my colleagues from Ingenico and Publicis for the proofreading. And thank you for being here.
Thank you very much.
You're welcome.
Of course, the audience, if you have questions, raise your hand. Oh, ready. Go ahead. Cool. Yes.
Yeah, go ahead.
So I repeat. How can you debug an obfuscated app?
Okay, it's really difficult, because if we add many features like that, it's really difficult for the compiler, even for Xcode, because Xcode will crash. And that's why we use some code injection with Hopper, and you can repackage and add some flags with Hopper and recompile your app and use it on the phone. I'm not sure if I'm clear, but we have to do the attacker's techniques to test our application.
Yeah, but I mean, if you receive a crash report with some obfuscated lines, how do you proceed to...
In fact, it's really complicated. And first, we need to remove each layers of security and find which fact caused the problem. Basically, there are not magics behind here. And in case of report, in case of any troubles, we can ask to our provider, which allow you to, our compiler provider, to send the report if we have some crash.
Yeah, but can you get back the the call stack of the crash, like if it's obfuscated. I didn't really get if it's possible with Hopper.
And the calls, you can get the call stacks for it.
Deobfuscated?
Yes, of course. But as I said before, everything will be flattened, and it can be really difficult for you to understand.
Yeah,
that's why we send
really
this call stack to the compiler provider.
Oh, okay. Is there another question over there?
I have a question about the device check you talked about at the end, sent to a server for a product and back. What kind of issues can it detect?
What kind of issue can the device checker provided by Apple can detect?
Yep. Apple has its own technologies to detect if everything is missing first. Some changes at the runtime, and if also there are some, if the sandbox has been broken. And Apple will also try to do the same techniques if they can access to anything else outside your sandbox, for example, and if Apple can, they will respond to you that this phone is really strange.
Other questions? Yeah.
Yep.
At which? Okay, so basically, what is the impact of the ciphering of all the code and also the images and all the other files would have on the performance and on the size of the package, right?
Yep. On the runtime performance, it's a little bit slow, because the compiler is smart enough to cover the major cases. However, it's slow, of course. And in terms of size increased, if we merge a lot of things like frameworks, and we remove dynamic libraries, and we put static libraries, and if we inline the code, just the inlining increase your binary size. It depends on your app, but it increase the size for more than 16 and 20% in general, because our apps is really huge. We have something like 500K of code. It's really, it's huge. We have a huge SDK and app. That's why we saw this kind of changes. But if your app is smaller, I don't think you will see some changes, some relevant changes, sorry.
Most of the attacks that you showed actually require attackers to physically be on the phone. Actually, why should we care about? Because Apple already has like Face ID and stuff like that. Why should we the overprotection?
Yep. And for example, you can try to hack some, to target and hack some celebrities, for example, if the purpose of the hackers. Or you can simply, some people are driven by free features. For example, if, okay, do not be offended. Okay, I give you an example of app. I'm using ZAM, which is a call conference app. And if this app have everything in the login page, if they put everything on the login security page, we can hook this API, remove this controller, remove this feature, and people will install this application. And some people are driven by free feature, like I said, and someone can also install some malwares inside the app. And if someone downloads this kind of app, for example, they can retrieve any kind of data they want.